Hello and good day to you. So I'm going to talk about Conway's Game of Life or Cellular Automata today. I'm doing this as a little bit of a break from playing with neural networks. What you've got in front of you is a live demo of Conway's Game of Life following his traditional rule set. Now, this is what the rules say. Conway's Game of Life has only 4 rules. Any live cell with fewer than 2 live neighbours dies as if caused by underpopulation. Any live cell with 2 or 3 live neighbours lives on to the next generation. Any live cell with more than 3 live neighbours dies as if by overpopulation. Any dead cell with exactly 3 live neighbours becomes a live cell as if by reproduction. Now, the real interesting thing about Conway's Game of Life is it's Turing complete, as in you could write a computer program in this. Doesn't seem to make sense, but it's true. There's a if you were to Google it, you could find if you sort of see these moving objects, you can build a shape in this which is they'll call starships or gliders, which will move across the screen quite succinctly. Now, that's not all. There's even shapes which will produce gliders and fire them across the screen called, and they call them glider guns. It doesn't even stop there. There's shapes which they call puffins, which will move across the screen and build glider guns, which will shoot gliders. I haven't sat down and programmed it up to make it produce gliders and glider guns and puffins. I don't find it that interesting to go to those extents. But it is interesting because it is a very simple set of rules, and yet it produces quite complex and quite pretty pictures. It'd make a great screensaver, is the way I'd put it. And this is the interesting thing about Conway's Game of Life. Now, Conway actually himself didn't seem as impressed with it as some people were. But it stands as a really powerful proof of what von Neumann defined as life. And von Neumann in the 1940s or thereabouts defined life as a being or organism which can reproduce itself and simulate a Turing machine. Von Neumann was thinking about engineering solutions which used electromagnetic components floating randomly in liquid or gas. And this turned out to be wildly unfeasible with technology available at the time. This is a guy that helped solve the Manhattan Project. Go and read up on him if you're interested. So, what makes Conway's Game of Life interesting is that it actually kind of manages to prove von Neumann right. And this is the really important takeaway. He's shown that this shows that it's Turing complete. You could do maths with it. You could pick a spot, create a bunch of glider guns, and use those glider guns as controls and switches, and it would work perfectly well. And you can run through some sort of evolutionary algorithm to try and figure out some method of running this process iteratively that would run that computer. I don't suggest you try it. I really don't suggest you try it. Nobody's programming in Conway's Game of Life, and if you see that little thing moving along the bottom, that's what I mean as a glider. But this is, fulfills the general requirements of artificial life. It's a Turing machine, it replicates itself, it's only 4 rules. And that should really make you sit there and think that a complex system doesn't need to be that complex and can be quite elegant with only a few rules and produce some quite beautiful outcomes. I say beautiful, it's geometric, it's elegant, it's pretty to watch it do its thing. It sort of proliferates in a way that we sort of find pleasing to the eye. So this is my sort of break from neural networks. I'm kind of trying to run something because I'm more interested with even Conway himself admitted there were other rules out there that would produce similar effects. And that's something that's got me interested in thinking about stuff. But I built this thinking I'd spend 5 minutes watching it play and then leave running and see what it produced. And I've just sort of sat here and found it interesting, found it worth playing with. And you can sort of see these gliders here, and sometimes it just builds mazes. Very simple algorithm, producing sometimes stunningly complex results, and that's why they call it life. Thanks, have a good day, bye.